The organic compounds, except alkanes, contain some structural feature which help us in classifying these compounds on the basis of reactivity. Yes, these are called as the functional groups. The functional groups are a group of atoms within the molecules which give the compound a characteristic chemical behavior. So if I have to define what a functional group is, can I say that it is an atom or a group of atoms that determines the characteristic properties of an organic compound? So for example, the simplest functional group that we have is a carbon, double bond carbon, and this class of functional group is called as alkenes. So if I talk about an example, the example is C, double bond C, and yes, it would have two hydrogens. So this is what is called as ethene, and the double bond is a functional group over here. Now, if I take one more example, I have ethane, which is CH3, single bond CH3. Now this is a poison, yes, but let me replace or let me add one oxygen to one of the bonds between carbon and hydrogen. So I get something like this, which is CH3, CH2, OH. Now what is this? Yes, this is now an alcohol. This is called as ethanol. And this is a slow poison. How is it a slow poison? Yes, this is the actual alcohol which people drink. And it kills them slowly rather than killing them instantly. So that is the difference that a functional group makes to a compound. So the first functional group that we have is alcohols. Now the group for alcohol is OH. The suffix would be ol, and the prefix over here would be hydroxy. Now how do we do the nomenclature? For the nomenclature, you would use word root, then you will add ane, ene, or wine, subtract e and add ol. So that would be your nomenclature. So if I have the first example over here, this would be methane. But if I replace the H with OH, this would become methanol. Now, what should be the common name? The common name over here becomes methyl alcohol. So similarly, if I take the second example is a 2-carbon chain. So that should be ethane. But if I replace the H with OH, it becomes ethanol. And the common name becomes ethyl alcohol. Yes, ethyl alcohol. Now, let's take one more example. 3-carbon, very easy. What should be the name? It should be propane. Let me show you a twist. So we'll take the first example over here and I'll replace the H with OH. So what should be the name? Propanol. And what should be the common name? It should be propyl alcohol, right? If I do one modification to the same, I change the OH. This becomes propan to ol because OH is placed at the second carbon. So now, you just saw what functional group is alcohol. Now over there, you were having oxygen. And you know that in the same group, that is group 16, just after oxygen, you have sulfur. So their properties should be same. So that means, can I change oxygen and replace it with sulfur? Will I get a different functional group? Yes, I would get a functional group which is different from alcohol. And this functional group is called as thiols. Yes, and the group would be SH. And the suffix would now be called as the thiol. And the prefix would be called as mercapto. And remember, these prefixes, we'll be doing it at a later stage. Now, if you take an example such as this, what should be the name? The name would be methane thiol. Please remember that the E would not be removed over here. It would be methane thiol. So the next functional group that we have is the aldehydes. Now, the group for aldehyde is CHO, or in the open form it is written like this. And the suffix would be Al, and the prefix would become formyl. So how would we do the nomenclature? For nomenclature, we will be writing the word root. Then we'll be adding the ane, ene, and wine depending on the bonds. We'll be subtracting E from it and adding ul. So that is how the nomenclature is done. Now let's take one example. If I take an example over here, which is a 1-carbon aldehyde. So this would be your aldehyde group. So 1 carbon means meth is the word root. Ane would be added and this would be called as methanol. And the common name, yes, the common name is very interesting. It is called as formaldehyde, and this is the simplest possible aldehyde known to us. Now, if I take one more example where I have a 2-carbon aldehyde. So what should be the name? The name would be called as ethanol. Remember, the carbon of the aldehyde has to be included in counting the word root. So the common name becomes acetaldehyde. Now, what happens if I replace the oxygen of the aldehyde with sulfur, like I did for alcohols and thiols? We will get a new functional group, and the suffix for that would be called as thiol, and the prefix would be called as thioformyl. So if I take an example such as this, the name is pretty simple. It would be called as methane thiol. That's it. So the next functional group that I have is a ketone, and for the ketone, the group is C double bond O, and the suffix would be -one. Yes, it will not be one, it is -one, and the prefix is oxo or keto. For the nomenclature, this would be having word root plus ane, ene, and wine, depending on the bonds. We'll subtract E and add -one to it. So that would be the name. Now let's take a look at the first ketone. Wait, is that a ketone? No, it's an aldehyde. Yes. So now let's try to take a 2-carbon ketone. So this is the one. But will this be a ketone? No, this is not a ketone. This is again an aldehyde. Let me try out one more time. I'll take a 3-carbon ketone. Yay! I found a ketone over here. So please remember, for a ketone, always see that on either side of the functional group, there would be one carbon each at least. The number of carbons can increase, but 1 carbon on either side is compulsory. If that carbon is not there, it would be an aldehyde. So the name of this compound will become propanone, right? And the common name is the nail polish remover, acetone. And this is the simplest possible ketone which has 3 carbons. If I take another example over here, this example, how will you do it? There are 4 carbons in it, so the name becomes butanone. Yes, but take a look over here. The ketone is on the 2nd carbon. So that means the name is butan-2-one. That is the IUPAC name. What about the common name? Can we write the common name? Yes. There is a method of writing the common name. So what you will do is, you will forget that there is a ketone and just count the number of carbons on either sides. So if I say on one side I have ethyl and on the other side I have methyl, so all I have to do is just place them alphabetically. So the name would become ethyl methyl ketone. Yes, so both the branches or the substitutions on the functional group have to be done and named alphabetically. So now let's take another example. So over here I have a 5-carbon ketone, and on the ketonic group is on the 3rd position. So what should be the name? 5 carbon means pentane. 3rd position will become pentane 3-one. And what about the common name? On this, on both sides of the ketone, you see there are similar substitutions, or they are same, which is ethyl. So the common name becomes diethyl ketone. Now similar to what we were doing before, if I replace the oxygen with sulfur, what do I get? Yes, a new functional group with the suffix as thione and the prefix as sulfonylidene. So if we see the name, the simplest ketone, the name would become prop-2-thione. Yes. Now let's talk about a special functional group called as the halo group. Yes, the group is represented by X, where X can be fluorine, chlorine, bromine, or iodine. And show what should be the suffix. There is nothing as the suffix, but it's a prefix that we'll use, which is halo, where fluorine becomes fluoro, chlorine becomes chloro, bromine becomes bromo, and iodine becomes iodo. What is so special? Halo groups have no suffix, only prefix. That is why for the nomenclature, it would be prefix plus word root plus ane, ene, or wine. That is the nomenclature, and that is what makes halo group special. No suffix at all. So let's take one example. So if I have one example, 1 carbon, so what should this be called as? Methane. But if I replace H with Cl, my name becomes chloromethane. Why am I writing it again? To make sure that you write only the first alphabet capital. So what should be the common name? The common name becomes methyl chloride. So whatever the word or whatever the word root is, you just add that as methyl and the functional group. So now, if we take another example such as this, what should be the name? The parent chain would be called as butane. But on the 2nd position, you have a bromine, so this calls as 2-bromo butane. Let's take one more example, a little complicated example. I have 5 carbons over here, and on one carbon I have a chlorine, and on the other carbon I have a bromine. So what should be the name? So the parent chain is named as pentane, and on the second position I have chloro, and on the third position I have bromo. So the name naturally should be 2-chloro-3-bromopentane. But is that right? No, that's not right. Because when you are writing it, you will have to follow the alphabetical order. So the name becomes 3-bromo-2-chloro-pentane. Remember that. It is 3-bromo-2-chloro-pentane, and always follow the alphabetical order. So now let's see another functional group. Yes, this is called as ethers, and the group is ROR. Suffix would be alkoxy, alkane, and the prefix would just be alkoxy. So the first alk over here represents the smaller carbon chain, and the other one represents the bigger carbon chain. So for the nomenclature also, the name becomes alkoxy, alkane. So if I represent it with different colors and correlate, you will be easily able to see what should be the nomenclature. So let's take one example over here. Over here, I have CH3O, CH3. So what should be the name? Over here, both the carbon chains are same. So it does not matter which one I take. So the name becomes methoxymethane. What about the common name? Yes, the common name is somewhat similar to what we were doing for ketones. So all you have to do is forget oxygen, and on both the sides, just imagine the chain. So the name becomes dimethyl ether. Now similar to that, if I take another example, this other example, on one side I have 2 carbons, and on the other side I have just 1 carbon. So what should be the name? The name would become methoxyethane. And what about the common name? It would be ethyl and methyl. So alphabetically, I'll place it, and it would be called as ethyl methyl ether. That's it. So now we'll talk about a special class of functional groups. This is called as the carboxylic acids and its derivative. So the first functional group that we have is the carboxylic acid. Now the group over here is COOH, and this is how it is written. So the suffix for carboxylic acids is oic acid, and the prefix is carboxy. So for the nomenclature, it's again similar to what we've been doing. We have word root plus ane, or wine, minus E, and you will add the oic acid. So this would be the nomenclature. So if I take one example over here, there is a 1 carbon carboxylic acid. Oh wait, I made a sin over here. See, there are 5 bonds. So replace this. Now, what should be the name? The name for this would be methane, but E would be replaced and it would become methanoic acid. What should be the common name? The common name of this is formic acid. Recall, this was found in red ants. Now, if I take another example where I have 2 carbons in the carboxylic acid group, so please make sure that the carbon of the carboxylic acid has to be included in the word root. So the name becomes ethanoic acid, and the common name is acetic acid. Remember something? 10% solution of acetic acid is called as vinegar. If we take a derivative of the carboxylic acid, it is acid chloride or acid halide. Now, how is it formed? I have the carboxylic acid, right? Now, if I replace the OH with a halogen group, then this would be called as acid chloride. So the suffix over here will be oil chloride. But if I replace it with, say, bromine, it would become oil bromide. And I can also have oil chloride and oil iodide. But the oil iodide is very unstable because iodine is very big in size. So for the nomenclature, again, very simple. Same thing. Word root plus ane wine minus E plus oil chloride, oil bromide, anything. So if I take the example, I have this example over here, 1 carbon acid chloride. What should be the name? This would be methanoyl chloride. Similarly, if I take another example, I have 3 carbons, right? So what should be the name? The name very easily would be propanoyl chloride. That is your acid chloride group. Can you guess what should be the prefix for acid chloride or acid halides? That is halocarbonyl, where the halo can be chlorine or bromine. So this would be chlorocarbonyl or bromocarbonyl. So the next functional group that we have is esters. Yes, the fruity smelling compounds. Now, what should be the group? The group over here is OOR. The suffix would be O8 and the prefix is R-oxycarbonyl. Now, when we talk about the nomenclature, for the nomenclature, take a very close look how it is written. It's a crisscross pattern. So the group that is exactly attached to oxygen comes first as alkyl, then you have alkene, and finally O8. So let's see how this crisscross method would be used for the nomenclature. So let me take one example. If I have an example something like this, the CH3 is connected directly to O, so the name would be methyl. One carbon over here means methane, and O8. So the common name for this compound is formate. Similarly, if I take another example, the example over here, what should be the name? The name would be methyl. Two carbons over here would be ethane, and for the oxygens we'll put O8. And the common name over here for ethanoate, we'll call it as acetate. And before ethanoate, since we had methyl, so the common name becomes methyl acetate. If we take one more example, something like this. Now the C2H5 goes here. Oh, wait. Is that right? This oxygen over here, what is it doing over here? Because we've been learning something else. Now this is where the trick to the nomenclature for esters come. And this is where everyone would try to confuse you for the nomenclature part. So let's take a look what we'll do to remove the confusion. Let's see. Now, what we will do is we'll just flip the molecule, right? And if you see, if I flip the molecule, this is what I will get. So always remember that the compound which is directly attached to this oxygen would be written first. So this will be ethyl propanoate. And that one would also, if I check this would also be ethyl propanoate, but you have to remember that the group attached directly to oxygen, that name has to be written first. Most of the people make this mistake, but I'm sure you will not make this mistake. So the next derivative of carboxylic acid that we have is amide. The group is something like this, which is CONH2. And if I replace the H with one more alkyl group, I get a different amide. If I replace another hydrogen, I get a different amide. The first amide that I get is called as the primary amide. The second one is the secondary amide, and the third is the tertiary amide. So in the primary, no alkyl groups on nitrogen. In secondary, one alkyl group, and on tertiary, two alkyl groups. So the suffix will be amide and the prefix would be carbonyl. So for the nomenclature part, again, the same thing. Word root plus ane in wine minus e plus amide. Simple, right? Now, let's take one example. I have an example over here such as this. CH3CONH2. So word root becomes ethane amide. Common name is important, which is called as the acid amide. Now, if I take one example over here, such as this is a primary amide, right? So the name, this carbon is included in the word roots, the name becomes propanamide, and it's a primary amide. Now, if I replace one hydrogen with, say, a methyl group, so this is what I get. So what should be the name over here? Over here, remember that CH3 is connected to N and not the parent chain, so it will be done as N-methyl. N-methyl, and there are two carbons, so this would be called as N-methyl ethanamide. Let's take one more example. Now, if we take another example, what I'll do is I'll replace the hydrogen with another CH3. So this is what I get. Over here, this is a secondary amide and this was a tertiary amide. Now, this tertiary amide, because two methyl groups are connected directly to nitrogen, so the name becomes NN dimethyl, two carbons, ethane amide. And if I take one more example, the example looks something like this, where two different substitutions are there on nitrogen, and in that case, you just do the alphabetical series. So this becomes N-ethyl, N-methyl ethanamide, and that is all for the amide group. So the next functional group that we have is acid anhydride. Now, what exactly does anhydride mean? That is without water. So how will an anhydride be formed? For that, let's take two acids. Now, what I'll do to the acids is I will add H2SO4, which is acting as a dehydrating agent. So a water molecule will be removed, and that is an anhydride gets formed. Now, how do we name the anhydride? While we are naming the anhydride, let's remove R and replace this with CH3. So what is the name of the acid that we get? Yes, it is ethanoic acid. Now, since ethanoic acid is combining to give me an anhydride, so the name of the anhydride that is formed would be ethanoic anhydride. Yes. Now, let's take one more example and I'll tell you how to name it. So, I have this example over here. All you have to do is break the molecule from the center and add OH group. So, you will get two acids. So, what is the name of the two acids that you get? Yes, that is a propanoic acid. So that means when propanoic acid is combining to give you an anhydride, what will be the name? Yes, the name would be propanoic anhydride. Simple, isn't it? Let's take this example. Over here, if I break it, how many acids do I get? Yes, I get two different acids. What is the name of the first acid that I get? Yes, it is propanoic acid, and the next acid is ethanoic acid. So now if an anhydride is formed, all you have to do is place the two acids alphabetically, join them, add anhydride, and that is your name. So the name becomes ethanoic propanoic anhydride. The next functional group that we have is amines. For amines, the group is NH2, the suffix would be amine, and the prefix would be amino. Now, this amine group is divided into three categories: primary, secondary, and tertiary. Now, the primary, secondary, and tertiary are as follows. They are only and only by the replacement of hydrogen with a R or an alkyl group. Now, how do we write the nomenclature? For nomenclature, you have to add word root plus ane, ene, or wine depending on the bondings minus E plus amine. That's the name. So now let's take the first example. Yes, it has only one carbon attached to NH2, so that would be meth and amine. Yes. Now if we take the second example, in the second example, what is it? That it's a secondary amine and the methyl is attached to nitrogen. So if you take a look over here, that methyl is written with N. Now why exactly is this happening? Because the CH3 is acting as a substituent, but the substituent is not part of the parent chain and it is connected to nitrogen. So you cannot write a number as 1, 2, 3. So now the next example that we have is something like this. Now over here, if you look carefully on nitrogen, there is CH2, CH3 and CH3. So that means there are two different groups attached. So what should be the name? It should be N-ethyl, N-methyl, methanamine. But is that right? No, that is not correct. Why? Because you would have to take care of the parent chain. And over here, CH2, CH3 is the parent chain and CH3 is acting as the substituent. So the name becomes NN-dimethyl ethanamine. That is the amine part. So remember, you have to take the longest chain and not go by the patterns. So the next functional group that we have is the nitro group. And what should be the group? That is NO2. What is the suffix? Nah, nothing. And what is the prefix? Yes, it has a prefix which is the nitro. And how do we write the nomenclature? Over here, for the nomenclature, we would have the prefix and we would have the word root followed by ane, ene, or wine. Now let's take one example. If we have CH3, NO2, the name would be simply nitro, 1 carbon, methane. Now, if I take a 3 carbon chain and on this carbon, if I have the NO2, so I would have to number it. So if I number, NO2 is on the second position, so I get it as 2-nitropropane. That's about it. So now the next functional group over here is cyanides, the most deadly. Now the group is C triple bond N and the suffix becomes nitrile and the prefix is cyano. So now let's take a look. How do we do the nomenclature part? Now for the nomenclature, very interestingly, note one thing. I will have the word root plus ane, ene, or wine, but no subtraction of E and add nitrile. So if we take one example such as CH3CN. So when I'm writing the IUPAC name, you will be considering both the carbons. So that means the name becomes ethane nitrile. But if I write the common name, now in the common name, because the CN would be used up as cyanide. So what should be the name? There is only one carbon that you will consider and the name becomes methyl cyanide. If we take another example, let's say I have 4 carbons. So for the IUPAC name, you will be considering 4 carbons. The name becomes butane nitrile. But if we talk about the common name, remove 1 carbon and your name simply becomes propyl cyanide. Yes. Next, we have isocyanides. Yes, the group would be N triple bond C, out of which one bond would be a dative or a coordinate bond. When it comes to the suffix would be isocyanide or it would be isonitrile. And the prefix, which will be used as a suffix only when it is being named, is carbylamine. Now, very interestingly, one thing that you should note that there would be no separate IUPAC names if you're using as isocyanide or isonitrile. Both can be used for anything. So for example, if I have a compound as CH3NC, so what should be the name? There is only one carbon that you would be considering and the name would become methyl isocyanide. Or as I told you that carbylamine will be used as a suffix, so the name would also become as methyl carbylamine. Exactly. Yes. And if I write the third possibility of the name would be methyl isonitrile. And now, this next example, how many carbons? 2 carbons. So it will be ethyl isocyanide or carbylamine or isonitrile. Anything over here. That is isocyanates. Over here, what we will be dealing with is functional groups, multiple bonds and side chains. So that means in one particular compound, you will be having functional groups, multiple bonds and side chains at the same time. Now it's not sure that you will only have one functional group or 2 functional groups or 3 functional groups. It could be any number of functional groups, any number of multiple bonds and any number of side chains. You should first remember that functional group would always be given the highest priority, followed by a double bond, then a triple bond, and finally the side chain. So this should be the priority order that you should follow. Now, what happens if I have 2 functional groups in the same chain? Now you have to remember I talked about prefixes. Yes, every functional group had a proper prefix. So over here, there's a priority series according to which we assign the priority to the functional group. Now, if in an example, there are 2 functional groups, say I have carboxylic acid and I have alcohol. So there is a reactivity series, and according to that reactivity series, or which is also called as the priority series, the functional group would be given a priority. And the functional group with a higher priority would be called as the primary functional group, and the other one would be called as the secondary functional group. The primary functional group would be used as a suffix, and the secondary functional group would be used as a prefix. So take a look at the priority series. Now in this priority series, carboxylic acid is having the highest priority. And if you come somewhere down over here, this is alcohol. So who's getting the higher priority? The carboxylic acid has a higher priority. So that means carboxylic acid over here is the primary functional group and alcohol is the secondary functional group. So if these two are present in any compound, then the suffix of oic acid would be used for carboxylic acid, but a prefix for alcohol would be used as hydroxy. So let's try to name few compounds. So if I have a compound such as this, what should be the name? Yes, over here, as we discussed, carboxylic acid will have a higher priority as compared to alcohol. So the name becomes 4-hydroxybutanoic acid. As simple as that. I have a cyclic compound. I have OH over here and a double bond O over here. So if I see the priority series, one functional group is a ketone and the other functional group is an alcohol. So again, ketone is having more priority over the alcoholic group. So what should be the name? The name would become 3-hydroxycyclohexanone. That is the name. Now, shall we talk something about advanced chemistry? What do you say? Let's take an example. Now, if I have a pentane ring over here, which is a cyclopentane ring, and I have C, double bond O, and I have OH. Now, how would you name this compound? If it would have been a benzene ring, then the name would have been pretty much easy. That we'll see in the next segment. But right now, how do you name this compound over here? Over here, if you try to say that this is cyclopentanoic acid, then you are taking into consideration only 5 carbons which are present in the cyclopentane ring. but you're forgetting there is one more carbon attached to the cyclopentane ring. Now, because the functional group gets a higher priority, so only the functional group would be my parent chain. Yes, and this cyclopentane would be my side chain or my substituent. So what will be the name? The name would be cyclopentyl methanoic acid. That would be the name. There's one more way of nomenclature for this compound, which is cyclopentane carboxylic acid. So this word carboxylic acid is defined for C double bond O OH. So you can either name it as methanoic acid or carboxylic acid. But at the same time, you have to notice that if you're using methanoic acid, then you are using it as cyclopentyl. But if it is cyclopentane, then you will have to write carboxylic acid. So this is how the questions are asked for advanced chemistry. Over here, what we will be dealing with is functional groups, multiple bonds, and side chains. So that means in one particular compound, you will be having functional groups, multiple bonds, and side chains at the same time. Now, it's not sure that you will only have one functional group, or two functional groups, or three functional groups. It could be any number of functional groups, any number of multiple bonds, and any number of side chains. You should first remember that functional group would always be given the highest priority, followed by a double bond, then a triple bond, and finally the side chain. So this should be the priority order that you should follow. Now, what happens if I have two functional groups in the same chain? Now you have to remember I talked about prefixes. Yes, every functional group had a proper prefix. So over here, there's a priority series according to which we assign the priority to the functional group. Now, if in an example, there are two functional groups, say I have carboxylic acid and I have alcohol. So there is a reactivity series, and according to that reactivity series, or which is also called as the priority series, the functional group would be given a priority. And the functional group with a higher priority would be called as the primary functional group, and the other one would be called as the secondary functional group. The primary functional group would be used as a suffix, and the secondary functional group would be used as a prefix. So take a look at the priority series. Now in this priority series, carboxylic acid is having the highest priority. And if you come somewhere down over here, this is alcohol. So who's getting the higher priority? The carboxylic acid has a higher priority. So that means carboxylic acid over here is the primary functional group and alcohol is the secondary functional group. So if these two are present in any compound, then the suffix of oic acid would be used for carboxylic acid, but a prefix for alcohol would be used as hydroxy. So let's try to name few compounds. So if I have a compound such as this, what should be the name? Yes, over here, as we discussed, carboxylic acid will have a higher priority as compared to alcohol. So the name becomes 4-hydroxy butanoic acid. As simple as that. I have a cyclic compound. I have OH over here and a double bond O over here. So if I see the priority series, one functional group is a ketone and the other functional group is an alcohol. So again, ketone is having more priority over the alcoholic group. So what should be the name? The name would become 3-hydroxy cyclohexanone. That is the name. Now, shall we talk something about advanced chemistry? What do you say? Let's take an example. Now, if I have a pentane ring over here, which is a cyclopentane ring, and I have C, double bond O, and I have OH. Now, how would you name this compound? If it would have been a benzene ring, then the name would have been pretty much easy. That we'll see in the next segment. But right now, how do you name this compound over here? Over here, if you try to say that this is cyclopentanoic acid, then you are taking into consideration only 5 carbons which are present in the cyclopentane ring. But you are forgetting there is one more carbon attached to the cyclopentane ring. Now, because the functional group gets a higher priority, so only the functional group would be my parent chain. Yes, and this cyclopentane would be my side chain or my substituent. So what will be the name? The name would be cyclopentyl methanoic acid. That would be the name. There's one more way of nomenclature for this compound, which is cyclopentane carboxylic acid. So this word carboxylic acid is defined for C double bond O OH. So you can either name it as methanoic acid or carboxylic acid. But at the same time, you have to notice that if you're using methanoic acid, then you are using it as cyclopentyl. But if it is cyclopentane, then you will have to write carboxylic acid. So this is how the questions are asked for advanced chemistry.